Hello students, welcome to Ma'am and Me Academy. I am your mathematics educator Bipul Babu, and today we are going to start a brand new episode which is second chapter from your book Polynomials. And this word is not new for you because you have studied this some part of this chapter in 9th standard. Let us see what we know about this chapter, polynomials. What is the definition of polynomials? I have written that an algebraic expression in one or more variables in which powers of the variables are non-negative integers. Now this is very simple definition of polynomials. What is this? An algebraic expression. What is an algebraic expression? Any variables, any variables along with an arithmetic operator is known as what? Algebraic expression. This can be x plus y, this can be x square plus x plus 1 or so on, and it can be simple variable x also. So these all expressions are known as algebraic expression, right? Now what are they saying? What is a polynomial? An algebraic expression in one or more variables. There can be one variable, there can be two variables, there can be more, in which powers of the variables are non-negative integers. That means the powers of the variable should be non-negative. That means it should be positive, because if you write like this, x to the power minus 1 plus x plus 1, this is not a polynomial. This is not a polynomial because the power of x in the first term is minus here, right? Minus 1. It is negative. So this can't be the algebraic expression or the polynomials, right? In the 9th standard you have studied in the first exercise to classify or to identify whether it is a polynomial or not. Let us see that also. It was written like this: x to the power minus 2, 1 upon x to the power minus 2 plus 1. Is it a polynomial? Now according to the definition, x is having a negative power, so you will say that it is not a polynomial, but it is. Why? Let us just simplify it. If we want to make this positive, the power positive, you can write it as x to the power 2 plus 1, right? So this expression can be simplified as x square plus 1. That means the power here is not negative. It was a false negative power, but this was a true power. It is x to the power minus 1, right? It should always be in the numerator. The variable should always be in the numerator. Now let us try to classify polynomials. All the things which we are discussing today are just a revision. It's just a revision of the 9th class. Now let us try to classify it on the basis of degree and on the basis of terms. Now let us see the classification of polynomials. The polynomials can be classified on two bases. First is terms and second is degree. On the basis of terms, let us see the classification of polynomials on the basis of terms. There can be one term, right? There can be one term in a polynomial. Then that polynomial is known as monomial. That polynomial is known as monomial. The meaning of mono is one only, right? If there are two terms in the polynomial, then it is known as binomial. It is known as binomial. Binomial. Now if there are three terms in the polynomial, it is known as trinomial. And if there are four terms or more, then we will say that it is a polynomial. Poly means many. Polynomial. Let me just repeat it for you. If there is one term in a polynomial, then that polynomial is known as monomial. If there are two terms in the polynomial, then it is known as binomial. If there are three terms in the polynomial, then it is known as trinomial. And if there are four terms or more, then that polynomial is known as polynomial only. Poly means many. Here tri means 3, right? And bi means 2. Now let us see the classification of polynomials on the basis of degree. What is degree? You have studied in 9th standard. What is degree? It is the highest power of the variable. What is degree? Highest power of the variable. Highest power of the variable. Let me give you an example for this. If I write an expression as x cube plus x square plus x to the power 5, let this be a polynomial. Okay, now what is the highest power of the variable? The highest power is 5 and not 3, right? The highest power is 5. That means the degree of this polynomial is 5. I hope you have understood the word degree. What is degree? It is the highest power of the variable. Now, if the degree of the variable is 1, if the degree of the polynomial is 1, then that polynomial is known as linear polynomial. What is that? Linear polynomial. Now, if the polynomial's degree is 2, then it is known as quadratic polynomial. It is known as quadratic polynomial. If the degree of the polynomial is 3, then that polynomial is known as cubic polynomial. Cubic polynomial. It is the classification based on the degree. Okay, so if a polynomial has the degree 3, then that polynomial will be known as cubic polynomial. And if the degree of the polynomial is 4, then we can say that it is biquadratic polynomial. Biquadratic polynomial. Okay, polynomial. Let us repeat this. The polynomial having degree as 1 is known as linear polynomial. The polynomial with degree 2 is known as quadratic polynomial. The polynomial with degree 3 is known as cubic polynomial. The polynomial with degree 4 is known as biquadratic polynomial. Okay, let me give you an example of each of the polynomial. Here in the first, okay, that is linear polynomial, you can see x plus 1. The power of the variable is 1. Okay, second example, x plus y plus 1. This is a linear polynomial because the power of the variable is 1 only. Okay, now let us see the example for second type, which is quadratic polynomial. Quadratic means the degree is 2, that means it can be x square plus x plus 1 or simply x square or any variable. Okay, a to z, any variable you can use. The third is cubic polynomial. The example for third is cubic polynomial is x cube plus x. Let it be. Okay, or you can write y cube. This is all the example of what? Cubic polynomial. Now let us see the example for fourth, which is biquadratic. You can write it as x to the power 4 or y to the power 4 plus 1. Simple, right? These are the examples for the polynomials of 1 degree, 2 degree, 3 degree and 4 degree. Now let us also see the example for the monomials, binomials, trinomials and polynomials. Monomial means one term, that means in the monomial you can say x, right? Or you can say 100. This is also a monomial, only one term is there. Okay. Now for the binomial you can say x plus y. There are two terms here. Or in the trinomial you can say x plus y plus z or z. Okay, there are three terms here. And in the fourth, that means in the polynomial you can say x plus y plus z plus a or so on. You can quote any example. What are we discussing right now? We are discussing the concept which you have already studied in the 9th standard. We are just revising what you have studied. After the revision, we will see the first exercise of this chapter, which is very simple. Okay, now let us see the two concepts. One is zero polynomial and the other is zeros of a polynomial. What is zero polynomial? As the name suggests, zero, we'll say this as zero polynomial. Okay, zero is known as the zero polynomial, but zeros of a polynomial is different from zero polynomial. What is it? Now let me just write an example. X plus 1. Okay, x plus 1 is an example of polynomial, right? Now if I put the value of x as minus 1, if I put the value of x as minus 1, then what will be the value of the polynomial? It will be 0, right? Let us denote this polynomial by p of x. Okay, polynomial of x. That means this is a polynomial of the variable x. Now when I put the value of x as minus 1, the value of the polynomial became 0. That means this particular value is known as 0 of a polynomial. This particular value, -1. Okay, so how can we define this zeros of a polynomial? The value of the variable, I am writing it for you so that it may be easier for you to understand. The value of variable, the value of variable for which the value of polynomial becomes 0. Polynomial becomes 0. I hope now you are able to understand it. The value of the variable for which the value of the polynomial becomes 0. After solving, you will get 0. That value is known as 0 of a polynomial. Let me give you another example. Okay, for zeros of a polynomial. For example, if I write x square minus 1, let this be a polynomial. Okay, this is a quadratic polynomial because the degree of the variable is, or degree of the polynomial is 2. Now, which value can I substitute here so that after solving the polynomial we'll get 0? You might say 1, right? Or some of you might say -1. Let us put both of them. Let us put -1 first. After putting -1 in place of x, -1 will be squared here, -1. You will get 1 minus 1 because the square of -1 is +1, right? So 1 minus 1 will be 0. So you got a 0. That means this -1 will be known as the zeros of a polynomial. Okay, now let us try to put the value of x as +1. Now 1 squared minus 1, that is 1 minus 1, which is 0 only. That means there are 2 zeros for this polynomial. Can you give me another value of x for which this polynomial will become 0? Can you? No. Why? Because the degree of this polynomial is 2. So I can give you a relation or a concept that number of zeros equals to the degree. That means if a polynomial has a degree 2, that means there are 2 zeros possible. Okay, if the degree of the polynomial is if the degree of the polynomial is 3, that means how many zeros of the polynomial? 3, right? So you can say that the degree of the polynomial tells you the number of zeros. Okay, I hope now you have understood the difference between zero polynomial and zeros of a polynomial. It is not necessary that 0 is always the zero polynomial. 0 is always the zero of a polynomial. It is not necessary. Let us see, you can see that here it was -1, which was zeros of a polynomial. Here it was -1 and +1. Okay, had it been x, the polynomial is x. Let the polynomial be x. Now what is the value of x for which the whole polynomial will become 0? It is 0 only. Now we can put 0 only. Now at this time you can say that 0 is a what? 0 of a polynomial. But it is not compulsory that for every polynomial 0 will be the 0 of a polynomial. Okay, I hope you have understood this because this was the base of your 9th standard. Okay, now let us see what we have to study in 10th standard. Now let us see the next topic, which is geometrical meaning of the zeros of the polynomial. What is the meaning of the statement? The meaning of the statement is that how can we tell the number of zeros from a graph? Okay, if the graph of any polynomial, is given, then how can we tell the number of zeros for that polynomial? So let us see that. I am taking the example for linear polynomial first, then we will see the quadratic polynomial, and then we will generalize the concept. Now for the linear polynomial I have taken y equals to 2x plus 2. You can see that the power of the x is 1. That means the degree is 1. The degree is 1. That means this polynomial is linear polynomial. Okay, now let us try to plot this on this graph. Okay, for which I am taking this box. Okay, this is x and this is y. Let us substitute the value of x as 0 here, then you will get y as 2, and if I substitute the value of y as 0, you will get x as -1. Now let us try to plot this. This part you know in the 9th standard, right? Now you have plotted the graph in the 9th standard. I assume that you know this. Okay, now let me plot this 0 2. 0 2 means x is 0, y is 2. X is 0, y is 2. That means this point. Okay, and minus 1 comma 0. X is minus 1 and y is 0. Okay, so this one. So let us join this point with this point. Okay, let us join these points. We got a straight line. Consider it as a straight line. Okay, it might not appear as a straight line, but for an instance consider this a straight line. Okay, now you can see that this line has intersected the x-axis only one time, right? You have seen this in this example. This line has intersected the x-axis only one time. Now tell me, how many zeros are there for this polynomial? Only one, na? I told you just now that the degree of the polynomial can tell you the number of zeros, right? The degree of the polynomial is 1, right? So there will be only one zero of the polynomial. So this can be identified from the polynomial graph. Okay, now let us try to understand it through the example of quadratic polynomial. Now let us see example for quadratic polynomial, for which I have already written the data so as to save your time. Here I have considered an example x square minus 4. This is a quadratic polynomial, right? Because the degree of the polynomial is 2 here. See, the highest power of the variable is 2. That means the degree is 2, and that polynomial will be known as quadratic polynomial. Now let us try to plot the graph of this polynomial. First of all, let us try to put the value of x as 0. You will get the value of y as minus 4, right? And if you will put the value of x as 1, you will get the value of y as minus 3. If you will put the value of x as 2, you will get the value of y as 0. Similarly, if you are taking the negative values of x, if you will put the value of x as minus 1, you will get minus 3, the value of y. Okay, and if you will put the value of x as minus 2, the value of y will be 0. This much you have studied in your 9th standard, how to plot a graph. Okay, we are concerned with the geometrical meaning of the zeros of the polynomial. Now let us try to plot this. The very first point is minus 2 comma 0. Minus 2 comma 0 will be this point, right? And the second point is minus 1 minus 3. That will be minus 1 minus 3. This is the point, right? Similarly, we can plot the point 0 comma minus 4. 0 comma minus 4 is this point. The fourth point is 1 comma minus 3. 1 comma minus 3 will be this point, right? And the last point is 2 comma 0, which is this 2 comma 0. Let us try to join all these points free-handedly. Okay, don't stop in between, just in the one go, like this. Okay, you will get a curve like this. This curve has a name. This curve has a name, which is parabola. What is this? Parabola. Kaun bola? Parabola. Okay, now let us see how can we tell the number of zeros by this graph. Let us assume that this is the graph of px. Graph of px. What is px? Px is polynomial of x. You can see this. Okay, it's a polynomial of x. Now the very first step is that identify whether the polynomial is of variable x or y. Here it is the variable x, right? If it is x, then see the x-axis. Then see the x-axis. So this is the x-axis. Okay. Second step is that see how many times this graph has intersected the x-axis. How many times this graph has intersected the x-axis. You can see clearly that this graph has intersected the x-axis at 2 points. This will tell you, these points will tell you the number of zeros. Okay, let us see another example. You'll understand it more clearly. Now let us see the example first, which says, look at the graphs in figure 2.9 given below. Each is the graph of y equal to px, where px is a polynomial. For each of the graph, find the number of zeros of the px. Now here are two graphs. This is first part and this is second part. This is a graph of y equal to px. Now what did I tell you? I told you first to see what is the variable inside the bracket, or what is the variable of the polynomial? The variable of the polynomial is x. If it is x, then see the x-axis. Okay, now the graph of this polynomial intersects x-axis at only one point. That means here only 1 0 is possible. 1 0 is possible. Okay, number of zeros is 1. Now let us see the second part, which is y equal to px only. Okay, it is intersecting the x-axis at 2 points. That means there are 2 zeros. Number of zeros are 2 here. In the third graph, it is somewhat like this. Okay, you can see from the book, but I'm drawing it for you. It is like this here. Okay, now you can see that it is intersecting x-axis at 3 points, 1, 2 and 3, right? So here we will get 3 zeros. How many zeros? 3 zeros. Now let us see the fourth part. Here you can see that it is intersecting the x-axis at only 1 point. That means there are only 1 0 here. Now let us see the fifth part, which is like this. They have drawn a graph like this. You can see from your book as well. Okay, it is like this. So here it is intersecting the x-axis at only 1 point. Okay, at only 1 point. That means there is only 1 0 here. The last part is like this. They have drawn the graph like this. It intersects the x-axis, I think 1 2 3. Okay, 3 parts. Okay, let us see how many times it intersects the x-axis. It is 1 2 3 and 4. That means the number of zeros are 4. I hope you have understood this topic. Now let us see the first question of exercise 2.1, which is, in this question they have given some graphs of the polynomial y equal to px. Now you have to tell the number of zeros from this graph. Now the very first thing which you noticed is there is x inside the bracket, right? That means the polynomial, in the polynomial there is x as the variable. If there is x as the variable, you have to see x-axis, right? You have to see x-axis. Now let us see. In the first part, the graph of the polynomial does not intersect the x-axis. Okay, it does not intersect the x-axis. That means there are no zeros of this polynomial. There are no zeros for this polynomial. Now let us see the second part. In this, the graph intersects the x-axis at 1 point. At 1 point. That means there is only 1 zeros of the polynomial. Okay, let us see the third part. In this, the graph intersects the x-axis at 1, 2 and 3. 3 points, right? That means there are 3 zeros of the polynomial. It is very simple right now. Okay, now let us see this graph. It is intersecting the x-axis at 2 points. At 2 points. That means there are 2 zeros of the polynomial. Similarly, we can see the next graph. It is intersecting the x-axis at 1, 2, 3, 4, right? So there are 4 number of zeros. Okay, 4 zeros of the polynomial. And in the last graph, it is 1, 2, 3. Okay, it is intersecting the x-axis at 3 points. That means there are 3 zeros of the polynomial. Okay, I hope you have understood this. I'll give you a certain different example from this y equal to px. Then you will understand whether to see the x-axis or the y-axis. Now let us see some different examples. I have drawn some graphs for you which represents the polynomial py. The very first thing which you noticed is the y inside the bracket, right? This means that these are the polynomials with the variable y. Now for this polynomial you have to see the y-axis and not the x-axis. Okay, if y is there inside the bracket, you have to see the y-axis. As simple as that. If x is there inside the bracket, you have to see the x-axis. Now let us try to calculate the number of zeros from this graph. Now you can see that the graph intersects the y-axis at only 1 point. You have to see the y-axis, okay, at only 1 point. That means there is only 1 zeros for this particular polynomial. In the second polynomial, in the second graph, it intersects the y-axis at 0 points. Okay, it is not intersecting the y-axis. That means there are no zeros for this polynomial. The other graphs you can see at your home, and you can comment the answer in the comment box. That is all for today. I'll see you in the next video with the new exercise 2.2. Till then, if you have any query regarding this exercise or the previous chapter, you can ask your queries or doubt on the email given here. Okay, till then, be safe, be happy, and stay at home and study with Ma'am and Me Academy.